It's the next day, so I need to continue working on the project, and I need to install a ground bus so I can tie the grounds of all my inverters and whatnot together at one point. Now, normally for grounding, you're supposed to use solid copper wire that's either bare or maybe it has green insulation on it. And I have some wire like that somewhere, but I don't know where it is. So I'm just going to install a ground bar, and when I find the special wire I use for that purpose, I will continue the install there. I'm going to install two of these bars. The first one is going to be for the ground bus. And I'm just going to eyeball it. I'm going to put it right here out of the way. Probably right there will be fine. And I already have a line. I had marked a line previously to help me line up screws, so that'll take care of that. To mount this bus bar, I'm using Phillips head stainless steel screws, if the camera will focus. And these are number 6 by 1/2 inch. And they're more than adequate for what I'm doing here. Okay, now I'm going to mark the second hole I need. There we go. Should be able to just drill it. And there's the bus bar for the ground bus, securely mounted on the board. It's not going anywhere. Those screws are more than adequate. And I think I got it mostly straight, like 99% anyway. I installed a second bus bar over there on the right there. That's going to be my negative distribution block for the small solar panel array that's coming into the building right now. Now, I use solar panels for a lot of different things. I don't just hook them up to a charge controller and a battery. I do a lot of different things with them that is kind of out of the ordinary, kind of thinking outside the box. And because of that, I need direct solar panel access through a variety of fuses to a variety of locations in my building. This setup I'm building here is pretty much the same as the one I have elsewhere in my property. I have 4 or 5 of them. And so the positive goes through fuses and the negative just needs to go somewhere where it can all be tied together. In this case, I'm going to use this bus bar to just tie all the negatives together off of the negative side of the circuit breaker, because this is a double pole circuit breaker. And then I will tie all my black wires into that. Black is negative and red is positive. That's generally the color scheme that I stick with if I can. What you're seeing there is a bunch of wires that are just temporarily strung up with alligator clips so I can use the solar panels while I'm building this board. So what I'm going to do now is get rid of all these wires snarled everywhere, use my distribution block for the negative side, and also install some wire management and try to get this looking a lot better. There's also going to be another voltmeter. I just ordered some voltmeters a few days ago and they're already here. And they're going to be different colors for different systems so I can tell what I'm looking at all the time. Up there on the left you see a blue voltmeter reading 18.7 volts. That's going to be switched over to the high voltage side of the solar panels, the big solar panels once I have them installed. Those will run around 60, 70 volts and maybe down to 50 at times. And this other set of panels I have, which is smaller, they usually go around 20 volts, maybe 18 volts, it depends. And so there's going to be a separate voltmeter with a different color, so I'll know what I'm looking at all the time. Okay, so now I'm going to go ahead and start cleaning up the wires. So the first thing I'm going to do is pull out this alligator clip. I just want to get rid of this alligator clip. It doesn't look professional at all. But sometimes that's how you have to wire things up while you're testing it. Here's the negative from the circuit breaker. This is a double pole circuit breaker. And it has my 2 solar panels outside, which are relatively small, 100 watt solar panels. And what I'm going to do is I'm just going to run this down to the bus bar. Probably do this first position here. And actually this wire is too short, so I'll probably change it out. It needs to be another inch longer. And I just put this wire in temporarily anyway. But I'll still try to get it in there. And it'll do for now. Maybe I'll leave it, maybe I won't. I'm just going to put it on there like that. And then once you have it in there, you can tighten down the screw. Make sure it's all the way in there. Make sure you're clamping the metal part of the tin wire, not the insulation. There we go. Got it in there tight. And I'm going to do some wire management later, but already it's looking better because I got the alligator clip out. Now I have a wire down here, which is I'm using it to power a piece of equipment, so it's just really patched in here. So this here is just temporary. And this piece of cable here actually powers my workbench. So I need to mount this in a safe way. So this is the one I need to redo. So what I'm going to do is I'm going to get some wire clamps so I can start organizing my wires. I like to recycle and repurpose things for cable and wire management, but this time I went out and I actually bought, specifically for this project, these are cable and wire clamps. They're actually quite large. They're suitable for an extension cord or a pretty thick cable, and they have nails already in them. Normally I don't buy things too specific, I just kind of recycle and improvise, but I think these are going to look good. Normally I use screws on everything. These clamps have a nail already in them, and I don't have any screws skinny enough to replace the nail. So what I'm going to do is go ahead and just try these out. If I don't like them, I'm going to pull them and use the hole to mount some other kind of clamping solution in its place. So what I'm going to do is I'm going to add a clamp right here, and that's where all my negative wires, it's hard to see that, all my negative wires are going to sort of congregate here and go into the bus bar. And then I'm going to add a second clamp. Actually, I may add two. And so probably one right here. And I'll probably have one up here at the top when I start using that area. I got 3 more circuits I can add up there at the top. Okay, I hate hammering nails. I really like to use screws, but I'm going to go ahead and give these a try. So I pre-drilled a really small hole right there. And I'm just going to go ahead and hammer this in and hope that it doesn't split the plywood. I think pre-drilling should be enough. Just added a second wire to the negative bus bar, and you can see it's already making things look a bit more tidy. I don't like wires that are just snaking and snarling everywhere and always moving around. Generally speaking, in electrical work, you want to keep the wires from ever moving. If it looks ugly, if it's glue or clamps or screws, you just want to go ahead and do that, because wires that move around will eventually fray. They may start arcing and they may break. They could start a fire. They could cause different types of issues that you would have to spend money troubleshooting and spend time. So having wires clamped and preferably in a conduit or a guide is a good idea. For the negative side, I'll need one more clamp, and for the positive side on the bottom of the fuse box, I'm going to go ahead and place one right here at right angles. Yeah, about like that. And I think that'll get me started. I don't know where the other clamps will be. It's kind of a figure it out as you go kind of thing for me. I got to think about it for a while and then try to figure out where I want my wires. Also, I haven't finished mounting all the electronics on the board, so I'm still a little undecided about that. The voltmeters here will require their own clamping for the wires. There's going to be 4 or 5 pairs of wires coming off of here. And I have a second voltmeter, which I'm going to snap in here in just a minute. Of course, this wire here that's negative will need to be extended. And generally speaking, when wiring any kind of a power board like this, you want to avoid crossing your positive and negative wire. If it's just 12 volts DC power and you have good quality wire, it probably doesn't matter. But generally speaking, you would want to avoid something like this. You don't want to take your negative and come across the positive like that, because that's basically a risk of a fire or a short circuit. In reality, on a board like this, it probably doesn't matter. And that voltmeter there is going to be fused at probably 1 amp. And that's minuscule and unlikely to cause any issues. But as a principle or rule of thumb, it's better to avoid crossing the positive and negative wires unless they're going through some kind of a conduit or some kind of second level protection other than the insulated jacket around the wire. Another kind of wire management technique you can use is simply to drill a hole in the board, like right here, have all your wires go in behind the board, and then have them come out in another hole wherever you want them. Now, I've done this kind of stuff before. I tend not to do it when I can avoid it, because the reality is that when you hide your wires behind a board that's flammable and made out of wood, you're not able to see the wires. If they're getting hot, you can't reach out and feel them. One of the most basic troubleshooting techniques in electrical systems is to simply reach out and feel the wire, assuming it's not high voltage. And if you feel it's warmer, then you know that wire is carrying more current or has more resistance, or there's something else going on. In many cases, the actual junction right here will heat up and the heat will travel down the wire, and you can feel your way to where the problem is. So in this case, I could feel this wire, it's getting warmer and warmer, and then I feel this bus bar and it's flaming hot. I know that's where the problem is. I found my problem. Of course, if it's high voltage, over 24 volts or so, you really don't want to be feeling around. You could shock yourself or electrocute yourself. Okay, I've added a second wire clamp right here, and these are fitting tightly into the board, so they feel pretty secure. I'm still going to look for something else that I can use that has a screw. But that'll get me started. Over to the workbench. So these wire clamps, I really like them, but I do not like the nail. So I'm hammering a nail into a board that has a $300 inverter on it. And that's just not going to work for me. It's just too much risk. The shot could go into the inverter and damage it. So I don't want to do that. So I'm going to do a little bit of modifications on these wire clamps. First I'm going to pull the nail out. And I have these little black self-tapping screws. They're really tiny. They're some of the smallest screws that I have. And I have several of them. I could probably find more laying around. Unfortunately, they're not as long as, they're a little longer than the wire clamp. So they're too short. However, I think I have a solution for that. First, I'm going to take a drill and my drill bit. This is my hand drill. And I'm going to drill out this plastic here. Now, normally you never ever hold what you're drilling. Drill presses, hand drills, you never ever hold on to what you're drilling with your hands. You use pliers if you have to, or a clamp. But because this is soft, bendy plastic and I'm drilling at low speeds and I know what I'm doing, I'm just going to go ahead and hold it. But just for safety's sake, I'm letting you know that you should never hold what you drill. So let's go ahead and see if I can drill this out. Okay, got the hand drill again. Now I got the next size up drill bit. Now let's see if I can drill it out a little bit more. I hope. Okay. So I can actually successfully drill these out and get a little bit more space for a bigger screw. But it still does not protrude out the bottom, unfortunately. So got another fix for that. So I'm going to get my wire cutters here. These are the flat kind. And I can take some of the plastic off here without too much problem, I think. Hopefully the camera will focus while I'm working on this. And one of my favorite uses for this type of cutter is actually to cut plastic. It cuts plastic really well, makes a flat cut. And this is not going to be the best looking solution here, but also you should wear safety glasses because they tend to throw plastic and metal at you while they're cutting. And I'm going to see if I can get a little bit more off there. About that much. Yeah, that should be all right. Let's go ahead and drop the screw in. There we go. Perfect. So now I have a wire clamp that's fastened with a self-tapping screw. Honestly, the screw's a little bit small, but I don't want to split the plastic. Right now it's pretty loose in there. I could probably find some slightly larger screws, but I'm just going to be thankful with what I have, and this is only going to hold some thin wires and keep them from running all over the board. So honestly, this is more than adequate. I think this will be more than adequate to hold a few thin wires onto my power board. I don't think this screw will come out from the plywood unless I really yanked on the wire. I really don't think it's an issue. So for my needs, I think this is more than adequate. Plus I can remove it easily, whereas the nail, it can be removed, but it's going to be a lot more aggravating. I have two of these wire clamps modified so far to hold a self-tapping screw, and I'm going to go ahead and give these a try. In order to keep from splitting the wood, I'm going to find a small drill bit. This one here looks too big, so I need to find a really small drill bit, and I'm going to pre-drill the wood. I could probably just put them right in, but I don't want to risk splitting the wood. I pre-drilled a small hole, but not all the way through. And I did find a smaller drill bit after the fact, but I'm going to go ahead and try to put this one on. See if I can do this while reaching around the camera. Yep, that's going in fine. I'm using a hand screwdriver. I don't want to mess anything up. Okay, let's tighten it a little bit more. That's tight enough. for now. Alright, so there's the wire clamp that will handle all of the voltmeters, and now I'm going to add my second voltmeter. Okay, this is another voltmeter. This one is actually orange. So when I saw these for sale, I just went ahead and got some. And I'll go ahead and pop that in and see where I want to put the wires. There we go. There we go. So now I can have as many voltmeters as I want because I have lots of this plastic screen track, and I could add a longer piece if I needed to. I don't think I'll need to, but this is an orange one, this is a blue one. This is going to be the high voltage bus, solar panels, when I have them all set up and ready. This is going to be my lower voltage panels, the 12 volt panels and 24 volt panels. And the voltmeters are going to be different colors, and I'll know at a glance which set of panels or which solar array is being indicated. In addition to that, I can simply print a label and put them right in here. Put a label under each voltmeter or something like that. One of the things I hate about installing things on a board is inevitably you find out the positive or negative wire needs to be longer or shorter. In this case, my positive wires are probably going to be okay, but the negative wire here is too short, and that's going to have to come all the way over here to this bus bar, which is on the right hand side of the screen. So that means you have to start using heat shrink. So at some point I'm going to heat shrink an extension onto this wire and have that come over here to the negative side. These two wires here eventually are going to be rerouted, so they're not going to be coming straight down. They're going to take a turn and go this way. But temporarily I've just let them come straight down here, as you can see them. And that means some of my positive and negative wires will be crossing until I can install the wires in their final location, and then hopefully I can avoid crossing the positive and negative wires. And for any of you who haven't seen the previous video in this series, this is a piece of screen track from a screen porch that I built. I have a lot of cutoffs and scraps, and these voltmeters snap right into it as if that was the purpose for which they were intended. It's like a poor man's DIN rail for voltmeters, and the voltmeters are quite secure. It's not perfect, but as long as you don't reach up and rip them off the board, they're not going anywhere. So this is a win-win for me. I have quite a lot of this, and I'm going to keep using it for this purpose. I moved the blue voltmeter, which is for voltages of about 100 volts, over here, and I disconnected it. And then I'm going to replace it with this orange voltmeter, which is for up to 30 volts. And I've already connected a spade connector, and I soldered an extension onto the negative wire. I added an additional wire clamp down there at the bottom for wires headed over to the ground bus. Go ahead and connect this to the positive so it can read the voltage. And I may adjust the wires later, make them look better. And I had yellow heat shrink only, so that's why the heat shrink's yellow. It doesn't match, but it's better than leaving a bare wire. You'll just throw it in this one right here. And you can see the voltmeter has come on. Yeah, I'll need to play around with the wires a little bit later to get them looking better, but there we go. It's actually an orange voltmeter. You can't tell from the camera, but it's actually orange, not red. And I really like the way it looks. I didn't really know about the orange voltmeters, but okay, there's the progress so far. It's looking slightly better than it did with the wires hanging down. Again, all this here is going to be removed or rerouted actually. So the negative comes in here for the voltmeter. And what I really need to do is figure out a way to get the positive wires to not cross the negative wires. But I'll deal with that later. I'm not too concerned right now. A friend and subscriber tipped me off to a affordable solar circuit breaker combiner box. So what I did is I cut out some of the DIN rail, and I'm going to point at it. Right there, that's been cut out. And I shortened it. I used 10 snips and I just cut it off there. And that's to make room for the combiner box. And this is the solar combiner box. It's plastic, has a clear door. You can open it up. It's got 4 mounting holes, 2 knockouts, and a DIN rail. And this was about $20 and very affordable. So I'm going to go ahead and install this on the power board. And It takes mini circuit breakers. I have another one coming in the mail, and I've got one on the board already, which will be going in this box permanently. So thanks for tipping me off to this combiner box. I think it's a good deal for someone who's a beginner and just starting out. I don't want to spend a lot of money. You can get them for about $100 made out of metal. It's just overkill for what I'm doing. $20, I can handle that. Okay, I drilled 2 holes. And that'll put the box in position, and then I'll get the other 2 holes in. And I'm using a deck screw as a punch so I can get a straight hole. And I'm using my Ryobi multi-tool because I cannot get a drill in there and I don't feel like taking the box down to drill the holes. Alright, there's the circuit breaker box or combiner box. I like how it looks for the money, and the circuit breaker that's going to go in there, actually there's going to be more than one. It's in the mail somewhere. I don't know when it'll be here, so I'll just leave it there, and when I get the circuit breakers, I'll do the install. To the left of the circuit breaker box, I believe I'm going to mount the first charge controller right here in this area. Back over to the workbench. Every power board I've made tends to have a lot of wires running all over the place, and it's unsightly. Also, it can be unsafe. If you snag a wire and accidentally pull on it the wrong way, it could short circuit and cause a fire. So wires should be clamped and held firmly and securely so they cannot move. And there's a lot of different ways to do that, but I think I found my new favorite way of doing it. And what it is these stick-on cable clamps. And I got 50 of them on eBay. What I'm going to do is I'm not going to use this adhesive pad. I'm actually going to drill a hole right in the middle and put a screw in there. Alright, I'm going to try this out and see if it works. I may do a small washer in there just to hold it flat, if I need to. So I'm going to go ahead and come over to the board and see if this works. And to anchor the cable clips, I'm going to try these 1/2-inch number 6 Phillips sheet metal screws. I've become very fond of these screws. I use them on everything, and I have different sizes. I also like to have USB power so that I can run lights or charge devices or anything I want to do, and I usually run it straight off of solar power. I had a hard time finding these boards. The ones I have are a little bit better than this one, but this is similar. Not cheap, but it's worth it. It takes power in here or here, and you can plug a solar panel straight into this, and you get 4 good USB ports that can put out a lot of current. This particular board is good for about 30 volts or so, and the capacitors are 50 volts. So, you know, you could put a 12-volt solar panel into this all day long. It's not going to hurt it. Even a higher voltage would not be a problem. The maximum voltage this will see is going to be from 20 to 35 volts, something like that. I'll need to mount this on the board, and the way I'm going to do it is I'm going to take these standoffs out, which are right here. I'm going to remove this acrylic plate and use it as a template to mark the board with 4 holes. Okay, I believe these are M3 standoffs, so I'll just take these out. I'm just swapping out these standoffs that look like this with the ones that look like this. And the reason for that is I'm going to use the M3 standoffs to actually mount this USB converter box directly on the power board. So next I'll use these standoffs here and use those to mount directly onto the power board, and then these larger standoffs will thread into those. And this will hold the circuit board in position on the power board, as you can see. So that part there will be threaded into the power board. And that way when I plug anything into these 4 sockets, it will stay right where it is and it won't shake loose or anything like that. I'm using the acrylic base plate that came with it as a template to mark all the holes. And it's pretty much perfectly square and level, so that's nice. I don't want to be looking at it later and notice that it's crooked. There's the 4 holes I drilled for the M3 standoffs, and they look pretty close to perfectly level to me. I like to use a 5mm socket right there, and I put the M3 standoff in that, and I can drill it right into the board. And there's the finished product on the board. Now I have 4 strong USB ports that can be run directly off of my small solar panels, and I need to use one right away for lighting. The other 3 I'll use for a couple of other things I have in mind. To power it, I'm just going to use the 2.1mm plug that it came with, and I'll need to wire that into probably a 5 amp fuse, and then I can start using it. Next job is to install a cable clip below this inverter here so that the 2 fan wires and the AC power wire can be securely held and hopefully protected from being yanked out or anything like that. So I think I'm going to put it right here below the inverter, about there. Yep, right there ought to do it. Okay, so these cable clips are going to work very well for me. I think I will use 2 screws per clip to make sure it doesn't bend, but these are fantastic. They're very easy to open, they're easy to drill and work with, and very satisfying to use. I'm not using them the way they were intended. They were never intended to have a screw in them, but sometimes you have to improvise to get the right hardware, and this is working really well. Also, these were quite cheap when you buy them in quantity.